interesting topic. So here to talk to us about GraalVM is Oleg, so please give me a big hand.
Excellent. 1, 2, 3. You can hear me. Excellent. I can hear myself. Good morning. I'm very happy to see all of you here at JFocus. It's an absolute pleasure and a privilege to be here. We're going to talk about GraalVM. It's a new virtual machine, a runtime, a platform. It can do very many things. I hope it will be a very interesting session to you, and you will learn something new. My name is Oleg. I work as a developer advocate for Oracle Labs, which is a research and development institution within Oracle. And if you don't have a chance to ask any questions, or you just want to follow up or ask something later, you can find me online. I almost universally go by @Slajev. I don't know, follow me, email me, ping me on GitHub. We'll start the conversation, and it will be very interesting. So we're going to talk about GraalVM, but before, there is a very important thing. Please do not make any forward-going business decisions based on the contents of this presentation. That is very important. With that out of the question, GraalVM. How many of you have heard of GraalVM? I am absolutely blown away by the response, almost everyone. So it's a high-performance, embeddable, polyglot virtual machine capable of running programs in different languages, right? So currently, we support a number of them. We support JVM languages, Java, Scala, Kotlin, Groovy, anything that compiles to the JVM bytecode. And we support other languages which are very different from those. So dynamic languages like JavaScript, Ruby, R, Python, and we even support running native languages compiled through LLVM toolchain to the bitcode, right? So we can run very many programs, and the promise of GraalVM is that you will be able to run them efficiently with high performance. You can mix and match them, and there are many things that you can do with it. However, currently, there are a couple of actual reasons why you as developers would maybe consider using GraalVM, right? So why GraalVM? First, it's a high-performance virtual machine, right? We do offer better performance for very many workloads, actual like normal user land workloads for running your applications. So if you develop applications that run on the JVM, who here are Java developers? Excellent. Who writes code in, say, Scala? A few people. We show really great results for Scala, so for you it would be even more interesting. But if you write applications in Java and deploy it through the JVM somewhere, I don't know, if you pay somebody for the cloud, maybe you can get a little bit of performance back by doing nothing, by just migrating to GraalVM, and then you would pay less for the cloud. So faster programs, faster runtime. There is a mode within the GraalVM that allows you to have a very good startup for your applications. It's a different mode of operation, and you have to make some effort to get that, but with GraalVM you can achieve almost instantaneous startup, kind of like other native languages offer you. And you can embed this VM so you can extend your applications with dynamic languages like JavaScript or Ruby or R. And you can mix the languages to choose the libraries and modules from the ecosystems which work for your problem that you're trying to solve the best, right? So Python, for example, is known for machine learning. So if you want to do some machine learning, maybe it makes sense to use Python libraries. And since GraalVM, you can run them within a single process, you can make the interop happen. So those are the benefits of using GraalVM. And this is what we will try to cover in this session. I'll talk a little bit about all those aspects. I'll show some demos, and we'll see how much time we have and which demos we'll get. So, but this is the things that GraalVM can offer you. So if you will remember one thing out of this whole session, because at the conference it's very hard to remember the full contents of the presentations. So I want it to be this one slide, right? If you take home one thing about GraalVM, this is it, right? GraalVM is a platform, is a runtime platform that sits between all kinds of different languages and it can be deployed into different contexts. So you can run your programs on the JVM, in the JVM mode, right? So it will be the normal JVM, the normal implementation of garbage collection, and everything that you know and love about JVM, and you can use all those languages there. Or you can run them as a Node application. Any Node developers here? Or somebody who does JavaScript on the back end? Excellent. So Node offers a very different computation model, right? There is an event loop, and then you scale it differently. So it's a very different deployment environment and runtime environment. GraalVM can offer you to run the same programs within the Node context. Or you can embed GraalVM into different native or Java applications. So this way, for example, we built GraalVM into certain builds of the database, of the Oracle database, experimental builds. And you can run, say, JavaScript and Python within the database, which can be very interesting. And one mode of operation, what I mentioned before, is the standalone native binaries. So you can compile your programs ahead of time and then get this machine code blob that you can throw on a server, and it will start very fast, and it will consume much less memory than normally a JVM deployment would, right? So many languages, many different environments where you can use it. As you can imagine, there are all kinds of possibilities here, what you can run where. And on top of that, there are other things that GraalVM can offer you. So there are plenty of use cases. However, don't get scared. If you are mostly a Java developer and you would download a GraalVM binary, you will get this zip archive. It will look very similar to the JDK download that you know and used like for the last 20 years now. So it's a zip archive. You can download the binary, and it will have the Java command, and it will have the Java C command for you, and you would know how to use that. So all the other features that it offers you are like, come on the side, right? They are additional value, so to speak. So you can use GraalVM purely as you use your JDK download. You can use it to, I don't know, build and compile your programs, or you can use it just as a runtime environment for your Java programs. And it will be compatible with Java. Currently, we provide Java 8 builds. Who runs Java 8? Excellent, almost universally. Who runs Java 9+ in production? Magnificent. Every year, there are more and more people who are migrating, so it's a good thing. So you can see there are also other things that you will not find in the normal JDK distribution, like the commands to run other languages, JavaScript, Ruby, or R, but you don't have to use them out of the box initially, right? So, and this is how it looks from within, so to speak, the architecture of the GraalVM as a runtime, because there are many components. Some of them come from different projects, so it's important to understand what there is and what actually works and how it runs your programs. So say we are running a Java application, so some application in the JVM mode on GraalVM. So as a platform, at the very bottom of our diagram here will be the normal JVM implementation, a Java virtual machine. It will be the hotspot version. What we do there in the GraalVM, and what you can do yourself if you would like, because GraalVM is an open source project, we include the Graal compiler. Graal compiler is a just-in-time compiler for the JVM, written in Java, and you can plug it into any JVM implementation that supports the JVM CI. The JVM CI is the Java Virtual Machine compiler interface, and this is a normal way how would you provide the third-party compiler to your JVM process, right? If you would have a third-party compiler that you would like to provide. It was added to the JVM to OpenJDK, I think in the JEP 2.4.3 in JDK 9, so a couple of years ago, and we backported that to Java 8. Because we would like to provide the binaries based on the Java 8. So through that mechanism, you get your normal JVM process with the Graal compiler. So at some point of time, the JVM will take and normally would do everything that it does normally with the program. It will locate the classes, it will load the classes, it will verify the bytecode, it will do everything that it normally does, interpret it, and then it will pass the bytecode to the JIT compiler, right? To the just-in-time compiler and ask, can you please transform this into the optimized machine code for me? Because this is what the just-in-time compiler does. It compiles your Java bytecode to machine code. So we put in a different compiler. We don't change anything else. Well, we make it by default enabled in our builds. And it runs, and everything else comes from the normal JVM distribution that you're using. With that, you can run all the JVM languages, right? Because your JVM knows how to run them, and they all compile to their Java bytecode, and Graal compiler knows how to deal with the Java bytecode. So through that, we can run Java, Scala, Kotlin, and so forth. Now, for other languages, the support is different, right? You cannot just, it's not that easy, say, to compile Ruby into the JVM bytecode, because, well, Ruby is a very different language, or JavaScript. The concepts are different, the syntax is different, everything is different. So normally, to provide a virtual machine, a runtime for those languages, you would build an optimizing compiler yourself, right? You would look at which syntax patterns are used, and you would define the rules how to translate them into the lower level language, either the JVM bytecode or the machine code or some intermediate representation, and then finally to the machine code. That's a lot of effort. Writing optimizing compilers manually is hard. The GraalVM takes a different approach. So what we require language developers to provide an interpreter for the language. Writing an interpreter is much easier because you don't have to think about the efficiency of how to compile it to the lower level language. You just need to figure out what the operations, what is the semantics of the operation. What does, say, A plus B mean in your language? And then you describe that in terms of the interpreter that traverses a program tree and evaluates the expressions. Normally, that would be a very slow approach, because it will be slow, because it doesn't compile your programs into efficient machine code. But what GraalVM does, it uses the Truffle framework, which is a framework for creating managed languages. So it offers you the API to describe the interpreters in a certain way, and it can compile them at runtime very efficiently. So you take the program tree, and it performs operations and optimizations on the tree level. So it kind of bakes certain nodes together and makes the optimization decisions and speculates which code path will be taken. So it optimizes the interpreter at runtime in a very interesting way using the technique called partial evaluation. But that's the whole other maybe a course of several sessions to describe that. But it compiles it at runtime and then gives it to the JIT compiler to compile the bytecode of the interpreter down to the machine code. So there are at least 2 levels of the compilation happening for those dynamic languages, right? But the reason is, and the takeaway is, that creating an interpreter for the language is much easier than building an optimizing compiler. So with that, with limited effort, we were able to create interpreters for those languages, JavaScript, including the Node.js API, Python, R, Ruby, and LLVM bitcode. LLVM bitcode is an intermediate representation for the LLVM project, which is the compiler toolchain. You can think of it kind of like a Java bytecode, right? So there are some operations, and it's lower level, and it's an intermediate step for programs written in very many languages, right? And through that, we can run dynamic languages, native languages on the VM, right? So there are different parts. If you are a Java developer, most probably you will be interested in the bottom 2 layers, right? So you would want to run your programs on the JVM in the JVM mode and just use a better, newer compiler as a just-in-time compiler, right? So if you want to see how it's all done and how it's all implemented, the good news is that it's all implemented in Java. Most of the project is in Java. The compiler, the necessary runtime bits, The interpreters for the languages, it's all Java. So what you can use your tools that you use daily. You can load it into your IDE and click through the references to see where it leads you. You can change it a little bit if you ever wanted to hack a little bit on the compiler, but never got comfortable enough with C++ and pointer arithmetics, then you can use it as a chance. But the reason is it's an open source project, right? The code is on GitHub. It's under permissive licenses. You can build it yourself if you would like. And we try our best to be a good open source project. If you don't want to build it yourself, you can download the binaries. There was a community edition built from the open source bits, which is fully functional. It can run all the same programs that the GraalVM can run. Download from GitHub, or you can choose to opt in into the Enterprise Edition, which comes with a more powerful compiler. So you can get additional performance boost if you choose that you need the additional performance boost for that. Currently, you can download that from the Oracle Technology Network. You have to accept the license, and you can evaluate that thing on your workloads and code. So this is what we're going to do now. We're going to evaluate the GraalVM release candidate 11. Because we released release candidate 12 yesterday, and I didn't feel like I'm going to redo all the demos. And we're going to evaluate that, and I'm going to show you a couple of demos, what it can do, and hopefully get you excited to try more, or maybe to figure out whether you want to play with this technology or not. Probably you should be excited about that. So I have downloaded that. I can show you that in my bin directory exactly what I showed you before, all those commands. I have installed the support for Ruby, R, and Python into my GraalVM distribution. By default, the zip archives that you download just support the JVM, JavaScript with Node, and LLVM bitcode. So the rest come in the form of jar files. And you can see that if I do this here, if I run this Java, and I do this version with a single dash, as all Javas do, you can see that it runs the GraalVM version, and it's built on the normal OpenJDK 1.8 192, right? So this is my normal Java. And since I talked about the high performance aspect of the GraalVM, I'm going to show you a demo. I'm going to show you a benchmark, right? I'm going to run this benchmark first because it runs for 40 seconds. And I will run it first. So here, look, ls, right? It's a benchmark, and I will run it without the Graal first. Come on, run, no, run, no, no. Yes, so I will just use my Java from my GraalVM distribution, and I will disable the JVM CI compiler, right? I will tell my GraalVM distribution that please do not use the Graal compiler, which is normally what you would not do, but just for the point of the comparison. So run no Graal. It will run, it starts, it will take 40 seconds. Let's go and see what this benchmark is. I have my Visual Code Studio here, and I have my benchmark class here. It's a very simple benchmark. How large the text is? Excellent. So it's a GMH benchmark that just transforms some values, takes an array, and creates a stream out of that, and just maps some functions over that stream, and then reduces all that to a single number, right? So it's a fairly synthetic benchmark, but also it uses the Java 8 features, which you probably use in your code day to day, right? Maybe not in the integers, but you most definitely process some information coming from database or in data store or like a series of events, and then you use Stream API to transform those, right? So it's a fairly normal, modern user-land Java code you can run, right? So in my on my machine here, one iteration of this method takes 190 nanoseconds per operation. Usually it's a little bit lower, so 170, 174. But my machine here currently is under quite a bit of load, so we have to do that. So now I will run this with Graal, right, to show you the difference. So here I will not disable the Graal compiler. So it will run with the full power of the GraalVM JIT compiler, and it will run the same benchmark. I will not show you the results because it will spoil, but we will wait for 40 seconds and look at this code, and then we'll see the difference. So now while we wait, who thinks it will be the GraalVM compiler will win this comparison and this second run will be faster? Excellent. How much faster? 2 times faster. 10 times faster. You know that the JVM is a very optimized state-of-the-art runtime environment, where if you get 1 or 2% performance boost, that's a very big deal, and people are very happy about that. 10 times faster. Oh my God. If you would evaluate other runtimes, and they would promise you a performance boost, and you expect 10 times performance boost, you're going to be disappointed, no matter the technology. But let's look at the result. So for this benchmark, indeed, the performance boost is incredible. So GraalVM with the GraalVM compiler can reduce this simple benchmark to execute 1 operation of the code to 10 nanoseconds. So before it was 180, 190, now it's 10. So it's almost 20 times faster, which is ridiculous. But it gives you 2 bits of information. First, that is, well, there are like no tricks, right? It's a synthetic benchmark, it's a small benchmark. Maybe you could like write other benchmarks to show different results. But there are no tricks. There are no like key in GraalVM or the GraalVM compiler to say that, oh, if you are running benchmark with 10 numbers, then please just do it really, really fast, right? There are generic general-purpose optimizations that make it possible. Mostly, it's the better inlining algorithm, the escape analysis that allows us not to allocate all the objects all the time, and polymorphic inlining, which allows us to perform really, really well on the stream API and the like, where collections API, where we have interfaces and then multiple implementations of the same interface. Like we have a stream, and every stream implementation has a map function, right? A map method, and it will be different implementations. And at runtime, you will call different those implementations. It's hard to optimize for the compiler, but with a better polymorphic inlining, Graal manages to do that. So one bit of information from this benchmark is that you can get a faster runtime than normally the JVM that you are probably currently using, right? The second bit of information is that you should not trust random benchmarks that people show you on the internet or at the conferences, because you will not get 20 times performance boost on your applications for a foreseeable future, at least with any runtime, even if you rewrite that in different languages. But you can get a significant performance boost. So we are trying, let me show you a couple more slides after this. So we've tried a number of scenarios with stream APIs. We wrote an article about that. We got a performance boost approximately, I don't know, 1.7, 1.8 times, twice, sometimes up to 5 times faster, depending on the particular benchmark, right? So the results vary, but the main takeaway is that it's significantly faster, right? What you have to understand as well, that it significantly depends on your workload, so on the actual code that you're running. Some code patterns are easier to optimize for certain compilers, right? For example, Java programs and C2, the default compiler, they evolved near each other for 20 years. So the performance team and the compiler engineers, they were looking at what code we are running in the industry, and they were like, we should make sure that this application runs fast. And at the same time, the application authors and the framework authors, they were looking into what the compiler does, and they were thinking about how can I write my code in a way that maybe it's not the most maintainable or easiest to understand, but it's nice for the compiler. So if you look into a framework like in Netty, a high-performance HTTP server, right? It's written in a way that you probably don't want to write your everyday code, but it's written like that for performance reasons. Or, I don't know, you look into the implementation of the for-join pool. Definitely not the code that you would like to get on your code review on a Friday night. However, right, so for other workloads, the results can vary. So what I want to tell you is that if you would like to experiment, try to evaluate it on the code that is close to what you are actually running in production, right? So if you're running web applications, try to evaluate that on web applications. If you are generating fractals, right? Try it on the benchmarks that generate fractals and see the results. So we see very good performance boost on different scenarios. Internally, we run a bunch of benchmarks, like a ton of benchmarks on every commit. And we see performance boost. The community edition is a little bit faster if you take the corpus of the benchmarks, all of them, and reduce that to a single number. It comes very on par with Hotspot. The enterprise edition is significantly faster. But again, your mileage may vary. So we show very good results on the code that comes from other JVM languages. Why? Because the other JVM languages produce different patterns of bytecode compared to the Java programs. So if you looked at the bytecode that Scala programs produce, it's very different from your normal Java programs bytecode patterns, right? So it's harder for C2 to optimize Scala programs, and we get a higher performance boost. So on Scala programs, and there were a couple of people who wrote Scala here, the community edition gives you approximately 10% boost out of the box. The enterprise edition gives you like 35% boost out of the box, which is not as impressive as 10 times, but is very significant. And if you, like say again, if you deploy your application to the cloud and you pay for that cloud usage, then saving like 35% of your cloud bill could be a very good business incentive to get to play with the new cool technology, if you need convincing your manager. So Scala, great results. Now there is this bit which deserves a very good discussion. Now there are two implementations of the virtual machine, which are kind of a little bit similar, and both are kind of backed by Oracle quite a bit. So one is the OpenJDK, and the other is GraalVM now. And so to avoid any confusion, they are different projects. They are mostly maintained by different teams of people, the Java group and the GraalVM Oracle Labs team. And we also have different visions, right? The OpenJDK is a reference implementation of the Java virtual machine, and it wants to be the best Java virtual machine it can. There is a process how to evolve that. They have millions of deployments all over the world. They value backward compatibility, stability, right? It's a well-established open source project. It's a great thing that it exists. Now, GraalVM, on the other hand, is a new kind of virtual machine. GraalVM wants to be the virtual machine for all the languages. GraalVM wants to be the runtime for people that need to compute something on a computer. So hopefully, in 10 years, you would, or in n years, you would want to run something in Python, and you will be like, oh, of course I need GraalVM, because that's how people run programs in Python. So the missions and the visions kind of diverge a little bit. So, but we both try to be good open source projects, and GraalVM uses the OpenJDK builds as a JVM platform, where we replace the compiler, and OpenJDK pulls the compiler from the GraalVM project and puts it into the sources and releases a version of the compiler with each release. So inside the OpenJDK recent builds, right, Java 11 or something, there is a version of the compiler that you can use. The Graal compiler is in there, right? To make use of that, you just need to specify a couple of command line flags, right? You unlock the experimental VM options, and you say, like, I want to use the JVM CI compiler. And since there is a version of the JVM CI compiler included with OpenJDK distributions, you will be running Graal compiler, right? It's a snapshot of the community edition of the Graal compiler, which, like, at some point of time, the OpenJDK group, like, they pulled into their sources, they update it regularly, but most probably this will not be the latest and greatest, the master master branch from the GitHub repository from the GraalVM project. What you can do, you can build that compiler yourself if you'd like, and supply the jar file and say that use JVM CI compiler, and here's the jar, right? And you can run just the compiler bit within your OpenJDK distribution, right? Within any JVM that implements JVM CI. I think currently it's OpenJDK. But hopefully, maybe more JVMs will do that later. I'm just looking for IBM people with OpenJDK. Not sure. Maybe it's implemented. So now your question will be, normally I get this question like, oh, so like how good is that community edition of the compiler, right? You say it's like on par with Hotspot. Why would I do this? Why would I run Graal compiler? So there are a number of reasons. And you have to understand that if the performance collapses to a single number, like this metric, is on par, it doesn't mean that it's always equal, right? It's an average temperature at the hospital. It tells you literally nothing about the performance on particular workloads. So Twitter are running GraalVM compiler, the Graal compiler with their, I think, OpenJDK distributions, and they see performance boost on their Scala microservices. And Chris is talking there about how they achieve that and what is the actual performance boost they see. But I also want to show you a different example of a benchmark. It's a matrix multiplication benchmark, and I took it from we took it from the keynote from the Oracle Code 1 last year, right? When they talked about the future of Java and that when value types will land, then certain operations will become much faster because we can pack data very neatly and there will be no overhead. So when they showed the benchmark, and I thought maybe we can run this benchmark now with Graal compiler enabled, right? What is significant about this is that it's a matrix multiplication, so there are like squares of numbers, and they are multiplied, row by column, as normal matrix multiplication goes. But in the innermost loop of this, we use the immutable data structure to represent a complex number. So every time we do s.add or something .multiply, we create new objects because they're immutable data structures. They're like easier to write. They're easier to reason about. They also produce quite a bit of garbage and strain the runtime capabilities, right? So we run this benchmark, and we get the numbers like this. On JDK 11, this is numbers also from this Mac, right? So they are not a rigorous scientific benchmark. On this Mac, I get on JDK 11 score of 17,900 microseconds per operation. When I enable the Graal compiler with just command line flags, I get the score which is 2 times better. Because Graal compiler is better at escape analysis, so we don't have to allocate all those complex number objects in the innermost loop. So we don't allocate the object, we don't do that unnecessary work, we reduce the GC pressure, so we don't need to collect the garbage all the time, so we do less work, and we get the same result because of the better compiler optimizations, and we get much better performance on this example. The Enterprise Edition gives you additional performance boost on that same thing, but, well, if you want to go to the last step. But this shows that the community edition of the Graal compiler can have significant speedups on very many workloads. So the same will apply for if you probably use Stream API or high-level abstractions. You can see the performance boost. If you allocate objects in your programs, probably it's worth figuring out whether the better escape analysis can give you the result. Maybe not. Maybe not. If you generate fractals and do low-level math operations, then maybe the results will be a little bit more disappointing as of now. We will improve them. The team is working. Very smart people are working on that. But currently it depends on the workload heavily. So you have to evaluate and you have to try. So once again, Chris from the Twitter team talks about how they use that at Twitter to save money on the cloud. And spoiler alert, what he's talking about right now, and I took those slides from a tweet about the FOSDEM presentation, is that they run the community edition compiler and they see something like 8%, 10% user CPU reduction time, and then they can additionally configure the compiler with parameters, like specify how much inlining it should do, or like play with the command line parameters for the compiler, right? And they can configure it in a very smart way using machine learning, and they get additional performance boost. So the actual numbers that they get is about 20%, which is very significant. So Scala Fox, take note of that. Maybe you should have gone there. No, I'm very happy that you're here. So this is about the high performance of the Java programs. You just have to download that, evaluate that on your code, and just see how it works. We have a little bit of time, so we're going to cover other topics. Polyglot applications. Why do we want to do polyglot applications? There are two major use cases for that, right? We would like to pick the libraries from the ecosystems where they are popular. So this is one use case, like using Python or R for data science, machine learning, and use them inside our normal applications that we write every day. This is one use case of which I know. And the second one is we have a system that is written in a certain language, and we don't want to maybe maintain it anymore, or it's hard, or we have the additional developers' power in like using different languages. And you would like to rewrite that system or evolve that system, but you don't want to rewrite it from scratch. Right? This is a problem with COBOL applications right now. Right? COBOL is a great language. There are not so many COBOL developers nowadays, but the programs still run. It would be very cool if we could just like throw them all away and rewrite them in Java, Go, or something. But the world just doesn't work like that. You cannot throw away old code that is working, right? You have to iteratively rewrite it piece by piece. So the interop capabilities of GraalVM, for example, allow you to rewrite your old Java applications that you don't want to maintain in Java anymore into, say, Node.js applications. And I know that some companies are evaluating that approach and experimenting with that. What I don't know if I can name them. So I will not name them publicly. But it's very interesting. You also can enrich your application with scripting capabilities. So Oracle has this platform called NetSuit. It's a service that any business or small company should use. It incorporates the CRM, the sales machine, the marketing machine, the inventory handling, all that, right? And they also have the marketplace for third-party applications written in JavaScript. Right, so you can install into your cloud account a third-party application in JavaScript, and it will serve just you. And I think they're using GraalVM's JavaScript interpreter to enable that extending capabilities. So I'm going to show you first the JavaScript or Node demos. And since there are not so much time, and I would love to show you like 20 demos or 30 demos because it's very versatile, I'm going to ask. So Polyglot applications. I have a demo of Spring application that is enhanced with R for data science. And I have a Node application which uses Java classes and R to like inside the Node application. Which one do you want to see more? Spring or Node? Let's not yell. Spring application. Plenty. Node application. Also plenty. Let's very quickly see both. Didn't expect that. So I have my Spring Boot application here. Let me make it a little bit larger. It's a normal Spring Boot application, right? What I would like to enhance it is with some R code. So my R is here, and this is the normal R file. This is how programs written in R look like, at least by a Java developer. Maybe R people write it a little bit differently. But I want to use it inside my Spring application. What I would use classes from the GraalVM Graal SDK jar. There is a Polyglot API that includes classes like context and engine and value to enable writing polyglot programs, because we need types, we need the definitions to represent values coming from other languages, right? So you include that jar, comes with the GraalVM. So to include it in my Spring application here, in my Maven thing, what I added a provided dependency, system dependency, and just said like, this is the jar where those classes are. right? When you run your application, final application on GraalVM, they will be included in the class path. But for the IDE, until the IDEs will catch up with this new development of GraalVM being totally awesome, and include that by default, we do this dependency trick. So now inside my Spring application, I have the resource that references my R file, right? And I inject that into my field. Now what I do is this. I create a GraalVM context, and you can see this context file comes from the GraalVM or GraalVM Polyglot package. I create a context and declare that as a Spring bin. This context now will allow me to evaluate code in other languages. So to do so, I get this other bin definition. I auto-wire my context, and I say, like, oh, now take this R source file and evaluate that within the context provided. So I get the value, this polyglot value that represents objects coming from other languages. This value you can use directly, or you can convert to Java classes if they conform to specific configuration semantics, right? If it's executable, you can convert that to a function. If it's a collection thing, you can convert that to a list and assume it's a list. And the GraalVM will do the internal magic to make it work so. There are limitations to what it can do in which directions, but we try to be as reasonable and as explicit as necessary. So I convert this function, and you can see that my R code defined just a single function here. I convert that to a function which is from data holder object to a string, and auto-wire that to this Spring bin. So this plot function is an R function. So next time Marvel talks about the most impressive crossover in history, remember that this plot function is an R function within the Spring application. So, and then I use it as I would normally use my Java util function object, which it is. Look, this function is anymore. It doesn't know about GraalVM anything. It's a Java util function, right? So you can pass it anywhere. You can use it in the functional programming. And then I just use it to render an object here at the load. How do I run this application? I will quickly run it from the command line because it's easier. Have the command. It's a Spring Boot application. It starts. It loads, it runs. I think I've built it before. I've checked that all the demos work just prior to the session. So it works. It starts a little bit. It has to load the R runtime library because we need to evaluate this R script. So it takes a little bit of time. But at the end, I will do load 8080. What we will see is when it loads. When it loads. You have to understand, when we talk about high performance, this is actually a very important point. We mostly talk about the peak performance, right? So when you warm up JIT, when you warm up everything, when you know the profile of the data that goes through your application, then it will become really, really ridiculously fast. But in the beginning of that, since Graal is a Java program, currently yet, Graal is written in Java, you need to warm up and compile Graal compiler itself, right? So it can take a little bit more time to warm up than you would usually expect. So now this graph comes from the R function, and it works. And our R function now uses the Java logging facilities to log whatever it is doing, right? So you can write programs that use the common infrastructure mixing different languages. I know another company that I don't know if I should name publicly are experimenting with providing the base framework written in Java using Netty. So they want their microservices to be Netty-based, to handle the low-level infrastructures, opening sockets, load balancing, and everything, right? Because they know how to run and operate and scale Netty. But they also want their Node.js developers to write business logic, because they have capacity in the Node.js JavaScript teams. So they use the GraalVM interop approach to provide a framework for the infrastructure, Netty-based, and then to register handlers on certain URLs, handlers being written in JavaScript. So this is how you do the polyglot. Another example of this polyglot is my application here. It's a Node application. It uses some big integer mathematics magic from Java standard library. So you can use that as just calling Java type. In JavaScript, it's even easier because JavaScript is dynamically typed, so you don't need to kind of concern yourself with, is it a value class, or is it a function, or is it something? So you just use it as normally you would use any normal JavaScript object. So I'm going to run this, but I will show you a different thing here, amazingly. So 5 minutes. Cut run sh, right? I would do this, and I will also provide it with a --inspect parameter. Inspect, S is important, inspect. So now I will show you the demo, not just of running the node application, but also using the common tools for debugging and like operating on different languages. Since from the point of runtime, all those languages, JavaScript, Ruby, R, they look the same, right? There are interpreters which are compiled through a certain like rule machinery framework, right? So what it means that tools, if they integrate with GraalVM, they can work for all those languages in the same way. So you can use the, say, the node debugger, the Chrome tools debugger to debug a Python program. Or you can use Visual VM to inspect the heap of your Ruby process, if you wish so. So localhost 3000. Boom. And we sit here on the breakpoint, and we will go further and further and further. And at this point of time, you can expect it will load R. What's happening? Did I step too far? Yes, we are here, and we will go inside the next function call. And what will happen is that we are debugging our function here, which was written inside a string inside our JavaScript application. While I do not personally encourage you to write code that way, inside strings, inside other languages, probably not the best way to maintain. You want to separate files differently, but you can debug that, which is absolutely amazing. We can step forward, and we can, something happened. So now we have 3 minutes, and I will show you the last demo, which is very important, and I show you a couple of slides. I will show you the basic example of this standalone native image that can speed up and start up in milliseconds. I will use the Micronaut framework, because that's a demo that works on my machine. It's a framework for Java web applications, right? They do a lot of at the compile time, so the startup is great as well. But also, they can compile that ahead of time to this executable, and it starts really fast. So I will do this inside the Docker container. I will start their basic application here. And you can see it takes a little bit for Docker to start up, but the application itself started in 90 milliseconds. Usually, it's a bit lower, but my machine is heavily overloaded at the moment. 90 milliseconds is really good for a Java application. Usually, they don't start that fast. You can also see, will show you that localhost 8080, hello, JFocus, boom, and it actually prints that. This is my basic application, hello, Oleg, and it responds to me. What's even better is that if I do the Docker stats to show you the memory consumption, then it's this application that takes 25 megabytes of RAM for runtime, right? So it starts really fast and consumes very little memory. How do we do this? There is a thing called native image. So languages, different languages, fast, excellent, tools, magnificent. Native images. It fully compiles ahead of time your Java bytecode to machine code. And it includes the static analysis phase where we find out every bytecode that could ever be executed, right? The methods called are the methods. And then reachable methods, all that is compiled inline together, and then it's wrapped into the ELF executable so your operating system knows how to run this. You can also compile static shared libraries, but it takes a little bit of time, but it includes your Java application, your dependencies, all the classes from the JDK that you're using, and certain components of the runtime, like garbage collection. Not the Java implementation of the garbage collection, but there is a specific bit in the GraalVM project that produces a garbage collection. And there are a bunch of limitations what it can do currently. Most of them are just required configuration. So it doesn't work out of the box, but like with a little bit of like effort, you can make it work for non-trivial programs. And you can get incredible startup and small memory consumption out of the box. But it takes a little bit of work currently. So the progress is being made as we speak about that. So if you are deploying into environments where the startup is really important, like tons of microservices or function as a service environments, and I think later at 4, Sean will do a Java functions session. So if you're into Java functions or serverless, you can maybe consider coming to Sean's session. And for those environments, native images just absolutely rock. So standalone. Scala compiler compiles and everything. We're working on Java 11 bits, so to provide the Java 11-based bits, and for the Windows version, because Windows doesn't work yet, because it's inherently, native images are inherently platform specific. So all the same, other things, you can check out the articles on the blog to see what are the things, cool things you can do with GraalVM. And you can consider trying it. And most importantly, remember that building a virtual machine is not easy, right? We can only run our code so many times, and we would like you to run your code to tell us what's not working as you expect, and what works beautifully. Because positive feedback is also very appreciated always. So join the conversation. Send us any questions, issues, try it. It'd be amazing. Thank you. Now, if I realize properly, there are no time for questions, but I will be removing my things here very slowly, so you can find a moment to talk about this. If you have any questions, I'll be happy to respond to them, or ping me online. You also had a